Hello, everyone, and welcome to Understanding Physics, in which I will try to teach you physics and hopefully you would understand the concepts of physics. So, today at General Physics 1, we will do one important chapter, which is doing physics, in which you will try to understand what physics is and how do you use numbers in physics. So, first of all, we want to talk about the branches of physics, first of all. So, physics has six different types of category from the Richard Wolfson's book. First, there is mechanics, in which it talks about motion as well as forces, which is based on F equals ma. The second is about wave, as well as oscillations and fluid. Oscillation and fluid, as we will talk about how a wave form and how it propagates energy even though it doesn't propagate matter. The third, we will talk about thermodynamics, in which we will talk about the transfer of heat from one place to another, as it will influence the material's temperature as well as other properties of a material, such as if it will expand or shrink. The next one we will talk about is electromagnetism, which will be on general physics 2. Electromagnetism talks about why is there a electric field and a magnetic field. And these are explained through the Maxwell's equation, and you will realize that both of these are related between each other. Next one is about optics, in which we will talk about light and how it interacts between different material, one of which is refraction, which is governed by Snell's law. The last one we will talk about is modern physics, in which we will discuss two important laws in modern physics, which is quantum mechanics as well as relativity, in which one deals with small objects and the other one talks about fast objects, fast and big objects. So what we will encounter from the previous chapters will be something that we see in everyday life. While modern physics is observable if you are working in a very small scale, such as atoms, or if you are working with great things, such as astrophysics. So, those are the branches of physics. And now we want to dive deeper into measurement and unit. So, in measurement and unit, there will be 7 units that is the foundation of the entire unit system, or the SI unit system. The first one is time. The second is length. The third is mass. And then we have temperature, electric current, amount of substance, and light, and lastly, luminous intensity. These have units second, meter, kilogram, Kelvin, amperes, mole, and candela. We'll be mainly focusing on these 3 units, while the last unit will be while the temperature will be discussed at the very final of the general physics course, which is chapters 16 until 19. Along with that, we also have geometric units such as radian and steradian, which discusses angles within 2D as well as within 3D. We will be mainly focusing on radians, but you might need to know steradian later on for other advanced courses. So, a part of these units, I will also introduce a the way of us using prefixes in order to signify the order of magnitude of a certain unit. You might have heard about kilometer, centimeter, or millimeter. They all come from this SI prefixes. There are lots of them, but I want to discuss some of the important ones, which is the giga, the mega, the kilo, the centi, the milli, the micro, and finally the nano. These units, these prefixes are attached to certain units in order to understand the size of the unit. For example, if I state that I have 10 kilometer, if I travel 10 kilometers, that means I have traveled 10 times 10 to the power of 3 meters, or about 10,000 meters. And this unit works for every single unit. And especially for the kilogram, the kilo is already 10 to the power of 3, so that the gram is 10 to the power negative 3 of the kilogram. But that means that we have certain issues, such as transforming between different units. And this is one of the greatest issues that I see most people struggle with. So I want to talk a little bit more on how do you convert between units. So the way that I always love to think of it is that if you have 1 kilometer, this means that you have 1,000 meter, which you have already figured out from these prefixes. And so you could actually figure out that 1 over 1,000 kilometers per meter is equivalent of you saying 1. So let's say if you traveled 10,000 meters and you want to transform it into kilometers, that means that you know that there is 1 kilometer for every 1,000 meter, or basically you are just multiplying this value by 1, which doesn't change its meaning, but it will change its unit from 10,000 meter to be 10 kilometers. There are also other kinds of units such as inches, feet, miles, and all the other empirical systems. But the one that I know most is that you have 12 inches within 1 foot, which is one of the ways for you to convert between inches and foot. Along this series, you will later encounter different units, and we will later discuss the transformation from one unit to the other based on this analysis. Next up, we want to first talk a little bit about how we write numbers in physics. So, in physics, we normally write numbers as a value from 1 to 10 at the front side, and then we will write times 10 to the power of a certain value. For example, we could just write the gravitational constant to be 6.67 times 10 to the power of negative 11, while at the back you will have certain units that we'll later discuss more on chapter 8 about gravity. But this is how we write numbers in physics. The first number tells you a lot about the precision of the measurement, while the backside tells you the order or how big the number is. So in here, you could see that the measurement is precise until 6.67, and then the third decimal place, 1, 2, is not yet known. It might be -5 or +5 of the value that you have here. So you could determine that 6.67 times 10 to the power of negative 11 could have a different number depending on its precision of 0.005 times 10 to the power of negative 11. And you would later see much more details about significant figures later on a demonstration that I will display to you. Another part of significant figures is that you can actually use this to figure out operations. For example, if you do multiplication between two numbers, let's say 6.022 times 10 to the power of 23, multiply that by 10.0. In here, you could see there are 4 important digits, in which that you could see that if you change one of the values, the entire value would be different compared to if you change the fourth decimal place. This has 4 significant figures, while in here you have 3 significant figures. And so, using this system, you could actually figure out that this is basically 6.022 times 10 to the power of 23. Multiply that by 1.00 times 10 squared, as it's the same thing. And you would figure out this to be 6.022 times 10 to the power of 25. But why didn't I write the other two? This is because of the precision in which you could measure the thing that you're measuring and then doing multiplication. And so the third digit is uncertain because you have uncertainty in your measurement, but you can guarantee that the other 3 values are as precise as it can be. So, how do you know the precision? Well, for multiplication and division, you only need to focus on the least amount of significant figures. In here, it is 3. Let's say if you do a multiplication or division with a 2 significant figure number, that means that the result will have 2 significant figures. The way that I could explain this very easily is that if you have A times B plus a certain delta A and delta B, you would have A times B, which is the value that you have, and also the delta A times B and the delta B times A. These values will later turn out to be about the next significant digit, as they will contribute more on that significant digit compared to the other three, for example, in here. And this is one of the importance in which significant figures must to be maintained, because if you don't maintain significant figures, you might you might miss out on some things, such as if I give you a dosage. No, sorry. For example, if I measure your temperature to be 30 degrees Celsius, but I have a significant but if I have a significant figure of 1, that means that my measurement could differ about 5 degrees Celsius, which couldn't really determine if you are healthy or if you are sick. Therefore, significant figure is one of the key part in which you need to do your operations with. So, a part of doing multiplication, you could also do addition or subtraction of significant figures. For example, you could you could try to find the difference of a proton minus a neutron. And let's say you want it to have a significant figure of about 4 significant figure. So I figured out the mass of a proton to be 1.673 times 10 to the power of negative 27 kilograms, and you would subtract that by the mass of a neutron, which is 1.675 times 10 to the power of negative 27, and you would get a result of negative 0.02 times 10 to the power of negative 27. And this is how you use significant digits in addition or subtraction. You just need to focus on the final parts. For example, in here, you have 3 decimal places. That means that the result should have 3 decimal places. Or you could actually transform this into 2 times 10 to the power of negative 30 kilograms. And so the loss of significant digits in subtraction is much more greater compared if you actually add things up. And so this is one of the main reasons why you need to measure something as precise as possible, so that you could know that your model is right or wrong. And this also determines how well you know certain constants in physics to be. So, we have already talked about the physics of using numbers, and also how do you operate using these numbers. So now I have an example question in which you have a car and you want to travel it for a certain distance with a error rate of about 0.5 kilometers, and you would have the fuel efficiency to be in liter per 100 kilometer of a certain fuel. This is the fuel efficiency. And finally, you have the price of the fuel per liter. So, the question is, how much fuel do I need to go from one place to another? Well, it might seem easy, but the concept of you figuring out this problem requires not only logical steps, but you could also do this through something we call unit analysis, in which we know that the distance is the length, while the fuel efficiency is the volume of fuel per length. Therefore, we could figure out that we could predict that the fuel that we need would be the distance multiplied that by the efficiency. But only doing this gives you a totally wrong answer, because they are both not in the same unit. As you can see here, the unit of the efficiency is liter per 100 kilometer. And the way for you to fix it is that if you have 100-kilometer unit, that means you have 100 of kilometers, or or you could write it as the liter over 100 kilometer to be the 100 kilometer, which is 1 unit over 100 kilometer, which is the unit of d. Therefore, you could obtain that the formula is d, multiply that by e over 100, and this is the fuel that we need to travel from one place to another. And so, how much money do we need to pay in order for us to get that much fuel? Well, the cost could be obtained by the amount of fuel, it's in liter, multiply that by the price. So it's the price times the fuel, or it will be the D times E times the P over $100. And this is the cost. And so if you know the values of each different variables, therefore you would know how much money you need to pay in front of the gas station. But then what is its relation with significant figures? So in here I have a computation of the same problem in which you have the distance, you also have the efficiency, and you also have the price of the fuel. So, observing this, I want to show you that the distance in here is not as accurate as you think. As you can see here, the line is thick, meaning that there is a certain error of about 0.5 in here. So we are going to be focusing on 3 significant figures. And for the efficiency, we want to focus about two significant figures. As you can see here, about 6.2, 8.3, and so on. And you can see that the black line here has a certain thickness but not as thick compared to the distance. But then if you try to compute the amount of fuel that you need, you found that, for example, in here, if you have the fuel to be 175 kilometer for the distance and the fuel efficiency of 8.3 liter per 100 kilometer, you would found out that you need about 14.5 to 5 liters of fuel. But here's the thing. You know that you have uncertainty. Sometimes that you might get very unlucky that your fuel efficiency is very low while your distance is very high, or vice versa. But if you actually do the computation only until the second significant figure of about 15, you would get within the ballpark of about 14 to about 14.5 until 15.5, which is still a precise measurement compared if you only stating that it is instead of you only saying that you would need about 10, as the amount that you need is about 14.5, you could state that you could just state it is about 15 liters. And this is why it is very important for you to know significant figures, is that you could know the error, so that you would know that if you do an experiment, the error could be coming from your measurement. Otherwise, if the error is larger, that means that you know something else is interacting with that system, in which you could study it in much more detail to find greater observations. And same thing with the cost. For example, if you figured out your fuel to be about 15 and then multiply it by the cost, you would get about 30 $30. And so if you check the graph here, you can see that it is about $30 plus or minus some value, but you could confidently say that it is about $30. And so this is why we really need to understand significant figures as well as errors so that we could actually understand physics and understand the world in a much more clearer picture. So that's all for this video. I hope that this helps, and if there is any confusion, I hope that you would actually leave it in the comment and I will later discuss it with you guys. So thank you very much, and I will see you guys later on the next chapter. See you guys later.